So today we will start the new chapter, that is irrigation and drainage. So before starting, the first and the foremost important resource is the water. So what are the important roles of the water in plant life? We will discuss one by one. As you know, water is the main constituent of the plant body, or you can say about 50 to 90% of the water is present in different plants. For example, succulent plants having more water and woody plants having less water. And besides the important constituent, the water also performed the several functions. For example, first and the foremost important function is the weathering of rocks. You all know there are two important methods of the weathering. One is the physical weathering, another is the chemical weathering. So water play an important role in physical as well as the chemical weathering. So it is the important weathering agent. Then water can also helpful as a absorbing material, or you can say whatever nutrients can be absorbed by the crop plants, they can be dissolved in the water. So this water play an important role in the absorption process. Then assimilation means fixation, or you all know photosynthesis is the important process of the plant life, and in photosynthesis one of the important reactant is the water, or you can say water and carbon dioxide can give rise to the carbohydrates, which is the main product of the photosynthesis. Then the another important functions of the water is the transpiration. Transpiration is the important process in which the water is absorbed by the plant roots, then it can be translocated within the plant, and after that it can be lost into the atmosphere in vapor form. So transpiration is the process in which the water is lost in the environment, or you can say in the atmosphere in vapor form, whereas the translocation means the movement of water within the plant body. And it can also play an important role in the temperature regulation, because the transpiration is the actual process of cooling. Means when the heat from the sunlight is absorbed by the crop plants, then water can affect the plant body and which cool down the temperature of the plant body. Then another important function of the water is the evaporation. As you know, whatever plants are grown on the soil, the water can be lost from the soil itself or the free water surface in the atmosphere where the plant body is not involved. This is known as the evaporation process. And evapotranspiration, because the evaporation cannot be directly measured in the field itself, because when water is applied to the plants or in the field, then the actual demarcation of the evaporation and the transpiration is quite difficult. So this can be combinedly known as evapotranspiration. This is nothing but the evaporation plus transpiration. Or whatever plants are grown in the field, whatever water is lost in the atmosphere, this is combinedly considered in the form of evapotranspiration. Then the water can also be act as a reactant, means in the photosynthetic process. The runoff means whatever excess water is moving over the soil surface towards the slope, it can be moved down after fulfilling the needs of the depressions. Means whatever water is firstly infiltrate into the soil depending upon the soil texture. If soil is sandy, then infiltration is more, and if soil is clay or you can say fine textured soil, then infiltration is less. And certain depressions are there, because always in the field the condition is not like that. Clear? So when the certain depressions can be fulfilled, whatever is the excess water, it can be moved towards the slope, and which is known as the runoff losses. Clear? and another is the reagent. As you know, there are various metabolic processes, and this can also be act as a reagent for different metabolic molecules or metabolic products. Then comes to the water resources. Means you all know whatever total water is present in the earth's surface, this is not utilized by the crop plants, and most of the water is ponded in the oceans, and which is not utilized by either human being or for crop plant point of view. So when we see about the resources of water, so most of the part is in the oceans, and about 97% of water is present in the oceans, and only 3% of water is engaged in different bodies, or you can say which is considered as the fresh water. And this water is the salty water, which is not utilized by either human being or animal, as well as the crop plants cannot be able to take this water easily. And rest 3% is mainly polar. Some water is in the polar belt, or you can say when the total earth is quantified, one is the polar region, another is the equator. So means polar means frigid zone, or where temperature is very low, and this is in the form of ice, which is in the melting form. And ice caps and glaciers, and this accounts about 2%. And another is the groundwater, or you can say soil moisture, and this accounts about 0.6%. Means whatever water is retained in the ground, which can be pumped out through various bores, either submersible pump or simple pumps, and the soil moisture which is retained in the soil, and this water is mainly utilized by the crop plants. And another thing means water is also present in the lakes as well as in the rivers, but the extent is lesser, that is 0.16% only. And certain water is also present in the vapor form in the atmosphere. So in the atmosphere, about 0.0009% only. Clear? So for plant life, our emphasis is on the either groundwater or soil moisture. As far as the sources of irrigations are concerned, in India there are 4 important sources of the irrigation. One is the river or canal, then open wells or tube wells, then ponds or tanks. Means these are the important sources of the irrigation, because irrigation is also necessary for the growing of the plants, and irrigation is nothing but the artificial application of the water for growing a successful crop. So this artificial water can be replenished to fulfill the needs of this groundwater or soil water. And the important sources are river, open well or tube wells, then tanks and ponds. Tanks and ponds are mostly common in the southern part of the country, or you can say South India. And the extent is about, the river or canal irrigation is mostly done in the country. About 40% of the irrigation is done with the rivers or canals, and about 37.8% through tube wells or open wells, and rest 14.5 and 7.7. So as far as the total annual rainfall of the country is concerned, about 1193 millimeter annual average rainfall of the country is there, and the India has the geographical, this is the annual precipitation. Precipitation means all the forms of the water which can be received over the earth's surface, and rainfall is most important component of the total precipitation, and other components are, for example, ice, fog, hail, dew, etc. Clear? But in the country like India, where tropical and subtropical belts are more, the precipitation part is covered by the rainfall. Clear? But in temperate countries like the European countries, the extent of rainfall is less and ice is more, for example. Clear? So if we quantify this 1193 millimeter, because this is 1193 millimeter means all over the total geographical area, and total geographical area of the country is about 329 or exactly 328.7 million hectare. So if this average rainfall is received over this entire surface, it will quantify about 400 million hectare meter. And 1 hectare meter means when 1 hectare is the land area and 1 meter is the standing water is over, and what is the volume, this is known as 1 hectare meter. Clear? And this is the quantification of this total rainfall. And 1 hectare meter is 10,000 cubic meter, and 1 cubic meter is equal to 1000 liter. So we can easily calculate the whatever the total amount of water received through rainfall in the total geographical area of the country. Then the total water is not utilized by the crop plants, so the available water of, or you can say the physical classification of water. Physical classification of water, there are 3 kinds of the water is available in the soil. One is the gravitational water, another is the capillary, and third one is the hygroscopic. This gravitational water means which goes beyond the root zone, means which is not extracted by the crop plants, or it will goes due to the gravitational forces. Clear? Or this is known as the free water. And this capillary water is generally held in the soil, and it is in between the field capacity and the hygroscopic coefficient. Hygroscopic means whatever water is adhere over the soil particle in the vapor form. So this capillary water is generally utilized by the crop plants, means the fraction of capillary water is utilized by the crop plants. And this hygroscopic water means which is tightly held to the soil particle, and this is in the vapor form, means this cannot be utilized by the crop plants. And this first one is the free water, which cannot be utilized by the crop plants, and only the fraction of capillary water, and capillary is the in between whatever saturated water is there in the soil pores and up to the limit of hygroscopic, where all the liquid water can split out. And when this capillary water is there, then which fraction is utilized by the crop plants, it can be known through the water constants. Another head is the water constants, and there are 4 important water constant. One is the saturation capacity, another is the field capacity, third one is the permanent wilting point, and fourth one is the hygroscopic coefficient. Means there are 4 important constant of the water. One is the saturation capacity. Saturation capacity means you all know there are 2 kinds of the pores are present in the soil. One is the macropores, another is the micropores. Macropores having the diameter more than 0.06 millimeter. Clear? and micro means less than 0.06, means when all the pores can be filled with the water, this is known as the maximum water holding capacity, or you can say the saturation capacity. Clear? Means whatever soil column is there, if all the pores, either they can be micro or macro, they can be filled with the water when either receiving of the rainfall or we provide the water through irrigation, then first stage is the when all the pores can be filled with the water, means whatever air is there, it can be escape out and all the pores can be filled with the water. So this is known as the saturation capacity. At this point the free water is there, means water is not any tension, means if we want to remove this water, this can be easily goes beyond the soil column due to the gravitational forces. Second one is the field capacity. This is known as the upper limit of available water, means water is available in between field capacity to the permanent wilting point. So this is considered as the field capacity is considered as the upper limit of available water, and at this stage whatever macropores are there in the soil, they can be filled with the air and water is retained only in the micropores, means smaller pores are filled with the water and larger pores can be recede with the water, and whatever water is there, it can be goes down due to the gravitational forces. So at this point, means at the field capacity, the water is in the tension measured 0.1 to 0.33 bar, means this is the upper limit of available water, and in different kinds of the textural classes, for example sandy, clay or silt textural classes, the tension measured at this point is 0.1 to 0.33 bar, whereas at the saturation capacity water was at zero tension, means there was no tension. When the crop grows, then water can be recede, means water level can be goes down in the soil itself, and the another point comes which is known as the permanent wilting point. Permanent wilting point is the lower limit of the available water, because the plant can take water only in this range, means between field capacity to the permanent wilting point, and this permanent wilting point means when the plant can wilt due to the deficiency of the water, means when the plant can be shifted into the 100% humid chamber, then it cannot retain or regain the turgidity, means it can be flaccid or leaves can be drooped out. This is known as the permanent wilting point. The tension measured at permanent wilting point in different soils is 15 bar. So water available to the crop plant is in between 0.33 to 15 bar only, or in certain soil 0.1 to 15 bar. And in this permanent wilting point level, the water is only retained in the adjored portion, means the water is tightly held with the clay complex, and all the pores, either they can be macro or micro, they can be filled with the air. And after that, when the soil is further dried, then the water is present in the vapor form, means all the liquid water can be loose out, and at this point the tension is 31 bar, or this is known as or hygroscopic coefficient. Then comes to the water requirement of the crop plants. The water requirement of the crop refers to the amount of water required to raise a successful crop in a given period, worked out as, or it can be represented as, the water requirement can be worked out with two means, that is, one is the demand side, another is the supply side. Demand side means whatever water is required for crop plants, and another criteria is whatever water is available for supply channel. So water requirement can be represented as capital WR. WR is the water requirement. This ET is the evapotranspiration, WM is the water used in metabolic activities, and the extent of water which is actually used in the metabolic process is very less, or you can say less than 1% only. And W is the unavoidable losses. Unavoidable means application losses, and WS is the water used in special purposes. So unavoidable losses are the losses in the application process. For example, when we provide the water from source to the field level, then whatever conveyance losses are there in the either irrigation channel or in the application method, these losses cannot be completely curtailed down, although they can be minimized by adopting the proper method or by adopting the proper conveyance mechanism. Means if lining or the channels are concreted, then we can minimize the losses, and if the channels are kacha channel, for example, then the losses are more. And special purpose means, for example, in case of the rice, the water is used for transplanting purpose, or you can say the puddling is the important process in which the water is stagnated in the field and the churning should be down, which is known as the puddling process. So this water comes in the water used in special purposes. For example, in case of the fiber crop, or you can say in jute or sun hemp, certain water is required for retting process. Retting means the extraction of the fiber from the stem. Clear? So whatever water is used in this process, this comes under the special needs. Means this is the crop specific. Means this water is not used in sugarcane, for example, or in case of potato or maize, but this is especially used in rice, in jute, in sun hemp, and the crop which is grown over the saline conditions. Means where soils are saline, then certain water is required for leaching down of the salts, which is known as the leaching requirement. So this water also comes under the special need. When we take this water requirement through supply side, then water requirement means water requirement is nothing but, note down the legends, IR is the irrigation requirement, ER is the effective rainfall. Means whatever total rainfall is there, or whatever total rainfall is received over the field surface, then total water cannot be utilized by the crop plants, and the portion of which is actually utilized or which can be replenished to the groundwater contribution, this comes under the effective portion of the rainfall. And delta GWC is the change in groundwater contribution. Means in different seasons the groundwater level can be either up or down. Means in the rainy season the groundwater level will rise, and in the lean period then it will goes down. So if water table is near to the crop root zone, then certain water can be directly utilized by the crop plants. So this comes under the groundwater contribution. Then note down the water requirement of some important crops. Means water requirement can vary due to the soil type, due to the situation of the growing, and the topography of the land, and season of the growing. Means the same crop can be grown in the Kharif season, same crop can also be grown in the Rabi or summer season, then water requirement of the same crop can also be varied. If the same crop is grown in sandy soil and the same crop is grown in the clay soil, then water requirement can also be varied. If the crop is grown, means for example if wheat is grown in the North India, wheat is grown in the middle or you can say central part of the India and southern India, then water requirement will vary. Clear? So there are various factors which can decide the water requirement of the crop. Certain factors can be crop related, means one crop water requirement can vary with the another crop. Certain varieties having more water requirement in the same crop as compared to the other varieties. Certain soil factors also involved. For example, reflectivity means if soil is clayey, then whatever sun rays are received over the surface, they can be absorbed in different quantity, and the radiation which can be transmitted back from hitting to the ground surface, this will also vary. So the another is the hydraulic conductivity. Hydraulic conductivity means whatever the total heat is received by the soil particles, it can be varied. For example, sandy soils having more hydraulic conductivity as compared to the clay soils. Likewise, the certain management factors can also be influence the water requirement of a particular crop. For example, if tillage is there, if weed population is more, then water requirement is obviously more. If irrigation method is adopting, for example, if flood method is adopting, then water requirement is quite different as compared to the precise method. For example, drip or sprinkler method is adopted, or if the regent furrow method is there and flooding method is there, means there is a certain difference between these two methods. So the water requirement of different crops, so note down the sum of the important crops with their water requirements. So draw a table with 3 columns. In first column there is the serial number, in second column there is the name of the crop, and in third column the water requirement in millimeters. So water requirement either can be quantified in centimeter or millimeter. It actually means hectare millimeter or hectare centimeter. So hectare millimeter. Millimeter means when certain millimeter standing water is there over 1 hectare land. Means suppose this is the 1 hectare land, if 10 millimeter water is standing, this is known as 10 millimeter, for example. And in surface method, about 6 to 7 centimeter water is required for one irrigation. Means less than 6 centimeter water cannot be applied through surface irrigation method. So note down, rice 900 to 2000, the unit is in millimeter. Then wheat 450 to 650, maize 500 to 800, sugarcane 1500 to 2500, then groundnut 500 to 700, soybean 450 to 700, potato 400 to 600, then cotton 600 to 750, then tomato 600 to 800, and banana 1200 to 2200. So these are the certain average water requirement of different crops. So 1 hectare centimeter is known as, for example, 1 centimeter, or likewise 1 centimeter is equal to 10 millimeter. So if water requirement can be quantified in the millimeter, it can also be in the centimeter. For example, in case of the wheat, if 400 millimeter is there, it means 40 centimeter. Then factors affecting water requirement. The factors which can affect the water requirement of a particular crop, there are 4 broad categories of the factors. One is the crop factors, means related to the crop. For example, crops and their varieties, their rooting habit, extraction pattern. Extraction means moisture extraction pattern, means if the roots are spreading near to the soil surface and certain crops roots can go to the deeper layers, so the water extraction pattern can quite different. Clear? Then canopy structure. Canopy means whatever the foliage is there in the plant, it can also influences the water requirement. Likewise, first factor was the crop factor, second is the edaphic or soil related factors, soil factors like hydraulic conductivity, reflectivity and thermal properties. Third factor is the climatic factors. For example, solar radiation, relative humidity, wind and temperature. Means they can also decide the water requirement of a particular crop. If relative humidity in a certain locality is more, then water requirement is obviously more, and if relative humidity is less, then water requirement is less. If wind speed is more, means more transpiration is there, more water requirement. Likewise, if temperature is more, then evaporation or whatever processes are there, they can be speed up, so water requirement is more. So these factors can also be correlated with the water requirement. For example, if solar radiation is more in the month of, for example, June, instead of in the month of October, then water requirement of a particular crop is more, means higher in the month of June as compared to the October. And another factor is the management factor. For example, the tillage, weed management, intercultural operations, nutrient management, plant protection measures, etc. Then comes to the irrigation requirement. So first of all, what is the irrigation? Irrigation is the artificial application of water to provide the moisture sufficient for plant growth and development. And this irrigation requirement is of two kinds. I mean, there are two types of the irrigation requirement. One is the net irrigation requirement and another is the gross irrigation requirement. So firstly, we take up the net irrigation requirement. It refers to the amount of water needed to replenish the soil water deficit in the crop field, and it can be worked out as, note down, NIR is equal to sigma I is equal to 1 to N, and then MCFC minus MCPWP divided by 100 into ASI into DI. So note down the legends. If this is the soil surface, for example, and this root zone of a particular crop is divided into different subdivisions. For example, this is the first layer, this is the second layer, this is the third layer. So this I1 means this first layer, N means up to the, for example, in this crop there are 3 root zones. So N is equal to 3. So note down the legends. NIR is the net irrigation requirement in centimeters. N is the number of layers in the crop root zone. For example, this is the soil column, this is the soil surface, and if the roots of a particular crop, for example wheat, can extract the moisture from this level up to this level, and there are two things: either we can test the water parameters or water constants with whole layer at once, or either we can differentiate it into the different subdivisions. Clear? So if there is only one fragment, then this I is equal to 1, there is, sorry, FC, I is there, I is there, clear? Like DI and this I, clear? So, and if there are 3 fragments, then this first layer has different values of all these parameters, second has different, third has different, clear? So, this FCI is the moisture content at field capacity in percent in the ith layer. Ith means either first layer, second layer or third layer. Second one, that is MCPWP, is the moisture content at permanent wilting point in percent in the ith layer. Then ASI is the apparent specific gravity. It is nothing but the bulk density of the soil without dimension. Means whatever bulk density is there, it is known as apparent specific gravity if unit is not considered. And then DI is the depth of ith layer. For example, if root zone is divided, suppose this is the 0, this is for example 20, then 40 and then 60. So DI is the 20 in this case. Another is the gross irrigation requirement. So gross irrigation requirement is means net means whatever total water is required for the crop plants, and gross means, for example, if a crop required only 400 millimeter water, but this 400 cannot be applied with precise manner. Clear? Means if we want to apply this 400 millimeter water, we want to require more than 400 so that this 400 can get by actual needy, or you can say can get by the crop plants. Clear? So if the efficiency of the system is more, then the gross irrigation requirement and net irrigation requirement difference is less. And if system is not good, then the efficiency is poor and the gross irrigation requirement is more as compared to the net irrigation requirement. Because for example, in case of the sugarcane, if net irrigation requirement is 1500 millimeter, but to supply this 1500 we can deliver more water so that we can fulfill the need of that particular crop. So it can be calculated with the whatever is the net irrigation requirement through this formula, and what is the application efficiency. For example, application efficiency of the surface system is, for example, 40 or 50%. In case of the sprinkler system, it is about 70%, 70, and in drip irrigation system, for example, 80 or 90%. So if efficiency is more, means if losses are minimized, then gross irrigation requirement and net irrigation requirement are quite equal.